everyone, today we will be presenting our lab report on production of bioplastic using potato starch. We are from group 1.
Hi, my name is Divyashree. My matrix number is J21A1077. So I'll be presenting the introduction part. So potato starch is one of the most important components for the manufacture of bioplastics, and this can be a good alternative to reduce reliance on plastic made from non-renewable sources like fossil fuels. Bioplastics, which are sourced from renewable materials, have the advantage of being compostable and emit lower greenhouse gases. In this experiment, the focus has been on potato as it is a source abundant in starch content and its characteristics are of a natural polymer. The purpose is to assess the effectiveness of starch-based bioplastics by incorporating glycerol as a plasticizing agent to create a more versatile and stronger type of biodegradable plastic. The experiment is able to illustrate one part of the solution for developing biodegradable polymers for various applications in order to meet the requirements and challenges of plastic pollution. And for the objective, there's two objectives for this experiment. Firstly, the objective of this study is to test potato starch as an ecological source of raw materials for the production of bioplastics, primarily due to its ability to serve as an alternative for petroleum-based plastics from its biodegradability and renewability perspective. Secondly, the aim of this work is to study the specific role of glycerol as a plasticizer on the flexibility and strength of potato starch bioplastics prepared with systematically changed thermal and chemical treatment. Thank you.
Thank you, V. Now, as for the materials and apparatus, in this experiment, we are using 5 potatoes, 1.5 ml of glycerol, 5 grams of starch, 100 ml of water, knife, potato peeler, tea strainer, and also a blender. The method of this experiment is, firstly, we must wash, peel, and dice the potato. After we dice the potato, we must blend it until it becomes into a paste. And then the paste will be filtered using a coffee filter or tea strainer. Then, the starch need to be wet and dry before using. And then add 100 ml of water and 5 grams of potato starch into a 250 ml beaker. And then put it onto the heater at 85 degrees Celsius for 20 minutes. And after that, mix the solution constantly, and 5 minutes in before finish the experiment, turn off the temperature and add the 1.5 glycerol, and then continuing to mix it constantly. And lastly, pour 45 grams of the solution onto the petri dish and leave the plastic dry in 40 degrees Celsius in the oven for overnight, and continue to dry at room temperature for 3 days. And lastly, method for biodegradability test. Firstly, cut the sample of the bioplastic into 7 uniform pieces, and then weight each of the pieces individually, and then label each of the pieces from the first until the 7th, and then bury all the pieces into the soil, ensuring consistent condition, and remove 1 piece per day and clean it gently to remove the soil, and then weight it. And the last step is record the weight of each day from day 1st until the 7 days to observe the degradation rate. And that's all. Next, let's us continue for the result.
For the results of this experiment, firstly, in this slide, the diagrams show bioplastics made from potato starch and commercial starch after being dried in an oven and observed over several days. From day 1 to day 4, the potato starch bioplastic show a decrease in weight, with an initial weight of 0.42 gram on day 1, dropping to 0.32 gram by day 3. This was due to moisture absorption and early degradation. On day 4, the weight slightly increased to 0.81 gram. The yield was negative at times due to moisture uptake. For commercial starch, the weight fluctuated slightly, starting at 0.45 gram and ending at 0.58 gram on day 4, showing more stability compared to potato starch. From day 5 to day 7, the potato starch bioplastic experienced significant degradation, with its weight decreasing from 0.81 gram on day 5 to 0.02 gram by day 7. The yield showed noticeable changes, indicating continued degradation. Commercial starch showed less fluctuation in weight, starting at 0.64 gram on day 5 and reaching 0.77 gram on day 7. showing slower degradation and more consistent performance compared to potato starch. Potato starch bioplastic began with a smooth texture on day 1 but became rough and brittle over time, turning crumbly by day 7. Its flexibility decreased and it became fully brittle by day 7. The appearance changed from clear on day 1 to heavily discolored by day 7, indicating more noticeable degradation. The texture became harder and the odor became increasingly sour, which is consistent with its degradation process. For commercial starch, the bioplastic retained its smooth texture for a longer period and only became brittle by day 7. Its appearance remained clear for longer but showed slight yellowing and discoloration by day 7. The odor remained moderate, with a slight sour smell that increased only slightly over time. Their degradation rate was slower than potato starch, showing minimal changes in weight until day 5, after which it showed gradual degradation, completing by day 7. The graph shows that potato starch bioplastic gained weight on day 3 due to moisture absorption, then lost weight from day 4 onward as degradation took over. The negative field highlights the effect of moisture absorption and degradation. For commercial starch bioplastic, the graph shows slower, more steady degradation. Minimal moisture absorption occurred and the bioplastic fully degraded by day 7 with a more predictable weight loss pattern.
Assalamualaikum and hi, my name is Nur Shakila Najah binti Isha and my number matric is J22A0320. Today I would like to present about our discussion of this experiment, which is bioplastic experiment. The conventional plastic derived from petrochemicals have a significant environmental impact due to their non-biodegradable nature, typically taking centuries to decompose. The persistence of these materials leads to widespread pollution and poses threat to ecosystem. In contrast, bioplastics are produced from renewable resources such as plant starch from tubers, allowing them to biodegrade more efficiently and quickly and minimizing environmental impacts. This report examines the degradation behavior and characteristics of bioplastic materials compared to conventional plastic, highlighting the implication for their use and disposal. The experimental analysis involved monitoring the weight changes of bioplastic and conventional plastic samples over a period of 7 days. Bioplastic samples made from starch, specifically potato starch and glycerol, were tested to assess moisture absorption and degradation behavior. Weight measurements were taken daily to observe trend and transformation throughout the experiment. From the result and observation recorded in Table 1, on day 1, the bioplastic sample showed an initial weight of 0.39 gram. However, on day 3, an increase in weight to 1.55 gram was recorded. This was due to moisture absorption after several days of rain. This weight gain was followed by a decrease to 1.04 gram on day 6 due to partial degradation and moisture loss. On the other hand, the conventional plastic sample showed a different degradation response. It recorded a peak increase in weight of 1.26 gram on day 2, finally declining to 0 gram on day 7. This rapid breakdown supports the notion that conventional plastic has more effective biodegradability in a short period of time. The addition of glycerol in the experimental preparation was as a plasticizer in the bioplastic mixture, increasing flexibility, but it also affected the tensile strength. Although glycerol increased workability, it made the bioplastic more brittle over time, especially after moisture loss. Initially, the bioplastic produced a smooth surface, but it became raw as degradation progressed. These aesthetic changes included an initial clarity that transitioned to opacity, marked by the formation of black spots from residual fibers during the drying process. Further, sensory observation notes a mild odor that increased slightly as degradation progressed. The recorded bioplastic degradation rate showed significant fluctuation over the observation period, highlighting its capacity for moisture absorption and loss. This behavior is in stark contrast to the more predictable and rapid degradation of conventional plastics. To increase the reliability of this experiment, it is important to create a controlled environment with consistent temperature and humidity, minimizing external influences on moisture dynamics and degradation rates. By implementing a standardized protocol for preparing and testing bioplastic samples, using accurate measuring instruments to weigh and measure materials to ensure consistency, standardize the starch drying process in a controlled oven to avoid inconsistencies associated with black or residual fibers. Additionally, conduct frequent sample evaluation for changes in weight, texture, and appearance, facilitating accurate detection of degradation processes. Use statistical tools to analyze data, uncover significant trends, and identify anomalies related to various experimental conditions, and maintain true records of all procedure and results to promote transparency and reproducibility.
Next is the question. For the first question is why we use potato as a raw material for production of bioplastic. Can you suggest other material? Potatoes are often used to make bioplastic because they have a low starch, which is a biodegradable and renewable material. Since potatoes are grown all over the world, they provide a cheap and sustainable raw material. Potato starch can easily be turned into film or molded shape, making it useful for many products. Another common material for bioplastic is cornstarch, which is also easy to process and has a lot of starch. Like potatoes, cornstarch is renewable and eco-friendly used for making bioplastic. Second is, what is the function of glycerol in the production of bioplastic using potato starch? Glycerol is used as a plasticizer to enhance or the flexibility and elasticity of the material. Without glycerol, the starch-based bioplastic would be brittle and likely to crack. Glycerol reduces the intermolecular forces between starch molecules, making the bioplastic softer and more pliable, which improve its stretchability and durability for practical use. Third question is, what is the process involved in the production of bioplastic? The process for making bioplastic starts with washing, peeling, and dicing potatoes, then blending them into a smooth paste. The paste is strained to extract the starch, which is wet and dry. The starch is then cooked at 85 degrees for 20 minutes while stirring constantly. 5 minutes before finishing, glycerol is added and the mixture is stirred well. The solution is poured into a petri dish and dried in an oven at 40 degrees overnight, then allowed to dry at room temperature for 3 more days, resulting in a flexible and biodegradable plastic. Conclusion. The experiment demonstrated a successful production and biodegradability of bioplastic using potato starch and glycerol. The bioplastic shows weight change due to moisture absorption and degradation over 7 days, confirming its eco-friendly nature. Glycerol enhanced flexibility but reduced durability over time. When compared to commercial bioplastic, potato starch-based bioplastic are simpler, cheaper, and more degradable in nature setting, making them accessible and environmentally friendly. However, they lack the mechanical strength, versatility of commercial bioplastic, which are more durable but require specific disposal conditions for effective biodegradation.